Well, it's the big day. I finally got the amp at the final stage of assembly. The only thing left to connect up on there is the power feeding the effects loop, which takes a line off the main B+. So before I connect that up, I want to check the B+ voltage where I'm going to be taking power for the effects loop, and then I will check it again once the loop's connected and see if that's dropping that voltage down too much. I will need to change a resistor in the power supply. So we'll check that when we get to the point of checking voltages. The other two wires that I do not have connected are the main high voltage secondaries from the power transformer. I need to do the testing of the transformer connections, the power and all of that before I put it to the board, just to make sure there's no shorts, nothing wrong, no over voltage, under voltage, before I connect that up and start checking voltages on the board. But before I do that, I want to check that I've got continuity from all of the off-board wires going from the board to whatever connection they go to. I need to make sure that those are all good connections, especially with running those wires under the board. One can break and you wouldn't really notice it because you'd have no way to see that. I actually did have one that did break off underneath, so when you look at the board you'll see that there's one yellow wire that goes up top to a turret up top. So I just want to make sure all of those connections are good. So we're going to check all the off-board wires right now. I have checked the components that I have the right values into the right turrets many times. I even just checked it now before I started filming, so I don't need to check those. I know the turret board is put together properly. I will double check the continuity of the jumper connections that are under the board as well though. So we're going to start that right now. You can do this either at your lowest resistance range, or you can even set it to continuity. Sometimes it's easier when you've got it on continuity just to listen to the beep rather than have to look at the ohm meter every time. So I'm going to start by checking all the wires going off the board. I'm just going to go clockwise, starting from this first connection all the way around, and make sure that all the connections are there. If that all checks out, we can proceed to doing the testing of the power transformer. We'll be doing some continuity tests on the transformers, making sure there's no shorts. Then we will power it up without connecting those secondaries and check what voltage we got coming out of the secondaries. And then the excitement starts. We'll connect it to the circuit and check B+, check the voltages all the way through the amp. If that's good, we'll put tubes in and we'll see how she's sitting. I don't think we'll do any sound testing of this today, but if this is looking good, I'm going to play it over the next few days, make sure everything's okay, do a good burn-in, and then next week I will film the run-through over in the studio. Checking our continuity of our connections, we have a ground that needs to go from this turret right here, and it should go to the ground lug. So I'm just going to check, and if everything's correct, I should get a nice beep. And I do, we're good there. I can even do it here. Okay, next is a white wire that goes from this turret, and it should go to the right tab of the bright volume control. So that should be here. And we're good there. The next one is the turret right beside it, and that should go to the right tab of the normal volume. We're good there. Okay, so the next connection goes from this turret, it's coax, and it should be the one going up to the overdrive volume control. Yeah, we're good there. Next connection is a ground connection. It should go from this turret here, and we should see it at this ground point, which also carries over to this ground point, to this ground point. So I get continuity all the way around, all the way to this connection, so we can assume that these two connections are good as well, since that's a daisy chain there. The next connection that we have going off the board is from the 220 picofarad, so the tone stack. and that should go to the right tab of the treble control. So this is the treble control here. I should get it here. Yeah. And we're good there. Okay, so next connection, we did treble control, is the turret next to it on this 220K resistor, and that should go to the left tab of the treble control. So that should be going to here, and we're good there. Next connection going off skips over a turret. We're on this turret, and is that soldered? Yeah, that's soldered on this turret, and that should be going to the middle of the base tab. So that should be going here. And we're good there. Okay, so the next one is going from, is this coax, which should be going all the way over to the left tab of the presence control. So that should be this connection. And yes, we're good there. Our next one is a ground. It should be going from this turret, and it should be going to the right tab of the base control. It also should carry over to the right tab of the master control. So again, it's a daisy chain. So connecting here, I should get continuity all the way to this ground. And we do. The next one is a white wire, and it should go from this turret right here, and that should go to the terminal strip just next to the presence. And there we go. We're good with that one. A red coming off this 82K right here, and that should go to this tab on the filter cap, and we're good there. Next one coming off, this turret on the board, and one goes to the output transformer. The other one should go up and over to this tab of the switch, and we're good there. This is where we start to get into the jumble of wires. So this is the one that I just tested here, that goes here. Also, there's a wire coming from the OT that goes here. That's this wire right here. We're going to check from this tab here on this, or this turret here at this end of the Zener diode, and that goes to here, and we're good there. We also have a red wire going from this side of the Zener, and that should go to this tab of the bias switch for 6v6 KT66. These are shrink wrapped, so we can't really test those. I know that that's where those wires are going. I was very careful connecting that up, so we'll just assume that one's okay. If we get bias voltage, proper bias voltages, we know it's right. Again, we also have two blue wires that go here. I can see where those are running, so we're okay. I checked those ones, and again, this red one, which is also got shrink tubing on there, so we can't check continuity, but that does go to here. So that's this blue wire here, this blue wire here, this red wire, and this red wire. I know those are all okay because I've checked them. We do have, though, a red wire going to this side of the can cap, of this can cap, and an orange wire that goes to this tab of the terminal strip. So we'll check that. So that is from this side of this resistor, this turret, and that should be going up to this tab here, and we're good. It also should be going to this orange connection that should be coming to this turret here. You probably can't see it, but yes, we got continuity to that. What else do we need to check? The primary wires, which are not connected yet, one will come in and connect to this turret right here, The other one will come in and it will connect to this turret up here when we're ready to connect those up. So continuing on, we have a white wire that's going to go to the bias pod. It straps across these two terminals right here. You can see this white wire coming up here, and it goes across these two terminals of the bias pod, and that connects, I'll get this out of the way, that connects over to this end of this 47K. And we're good there. I must have some dirty tips going on here. The next thing is a yellow wire going from this capacitor. So this is that wire that came off the bottom, and I had to solder it on the top because there was just no way I was going to take this whole board out of there, unsolder everything just to solder that in underneath. That's another good point. I like the look of this, but it is more difficult for maintenance, as I mentioned before. So anyway, this yellow wire, and we can see where it goes. It goes from here and it goes to here, and we're good with that. There's a yellow wire over here too on this turret, and it should go to this tab. So yeah, we're good there. We have an orange wire that should be coming from the 82K here, and that should be going to pin 1 of V4. So that should be going right to here, and we're good there. The next one is an orange wire that should go to pin 6 of V4, and it should go from up here right off this 91K here. So that should be this orange wire coming here. And yep, we're good there. So the next one is this red wire coming off of this 1K5 2-watt resistor, and that should go, that's the negative feedback to the output transformer. So that should go to the 16 ohm tap on the selector switch. And we're good there. The next wire that comes off is a yellow wire, and it should go from this 100 nanofarad capacitor here, and that should go to pin 7 of V4. That should be this yellow wire coming right in here, and we're good there. Okay, next one is a blue wire. It should go from this resistor, this 22K resistor, and it should go to pin 3, the plate of Triwatt of V4. So that should be going right to, it's a little hard to reach sometimes. Yeah, there we go. That's this blue wire going to pin 3 here. The next one should be a yellow wire, and it should be coming from this 100K here. Yeah, this yellow wire, and we can see it's connected. It should be right here, and we're good there. Next one should be a blue wire off of this 2K2, and that should be going to pin 8 of V3. So that should be this blue wire right here, and we're good there. Now we should have an orange wire going to pin 6 of V3. So that should be this orange wire, and it should be coming from right here. So we'll check that. Yep, we're good there. We should have a yellow wire going from this 560K. That should be this turret right here, and that should be going to pin 2 of V3. That should be this yellow wire going right here, and we're good there. Then we've got an orange wire coming from this 100K, this turret right here, and that should go, well, we kind of can't get at it. I had some issues with that, and I don't want to disconnect this now. Like I say, I did check this, and we have the continuity in all the places we need. I don't presume I'm the only guy who's ever put an effects loop and the relay board in this amp, but I might be. It was really kind of frustrating. It's one of the things that delayed me. I thought I was going to have this done last week, but I had to actually refabricate some stuff to mount the relay board. I think what happened, let me just get this out of the way and I'll kind of tilt the chassis up and kind of show you what's going on. The relay board is right in here, and it goes, it's about this wide, and it's underneath the effects loop board, which is right here. I think in looking at pictures of other people's builds online where they didn't use the effects loop, I think normally this is where the relay board is mounted in my amp, right here. And looking at other people's builds, it looks like the relay board is actually mounted a little higher, so up in the center of the chassis. I think they had to move that relay board down to make room for the effects board going into mine. Like I say, both of these things are optional. I was kind of, I did detail this, and I will show you what the problem was there. I was not, it's one of a few things that I found could be done a little better on this kit. You know, I'm not making a complaint overall again. This is a lot of stuff to add in. I'm going to show you here what the issue was. Like I said, I'm installing the effects loop and the relay board. Basically, I'm doing the whole shebang here. But the issue that came up, like I said, they had to, it looks to me like they had to drill the holes for mounting the relay board and bring it down this way, closer to the bottom of the chassis, which is fine. But what they didn't notice was that by doing that, and I don't know if you can see, but the relay board is kind of cocked out at an angle. It's a little bit toward the front of the chassis at the bottom compared to the back. When I was trying to mount this, I noticed that it was sitting cocked, and I didn't want to tighten these nuts up till I sorted that out. So I took a look, and what I saw was this right here. You can see that this electrolytic capacitor is sticking out so far that it's over top of pin 1 of V1 here, and it's actually sitting right on top of V1. And I'm glad I noticed that the board was cocked, and I didn't just try and force that nut to tighten this down, because we would have had a lot of problem here. That would have bent this pin probably right out of the way. It may have even come in contact with the can of the cap, which is okay. It's not grounded anywhere, but you know, you could have some issues with that. Also, we were pretty close to the input grid, and this wire coming off of the input, the grid resistor right here. So that was a bit of an issue. I wasn't too sure what I could do about that. The board is mounted on, there's a standoff underneath the board on each side here. So the board does stick into the chassis probably around 1/4 of an inch. So I did have a little bit of room there. I'll just go to this next picture here and just show you a close-up. You can see here's a close-up of that cap sitting right over top of pin 1, and again you can see how close the lead of this grid resistor is to the top of that can. So that was the problem, and it took me a little while to kind of figure out what I was going to do about this. If you saw in the picture, that cap was kind of sitting here, and that's as far as everything goes over this way. So I was able to leave these wires up in the air where they should be. I didn't have a lot of problem with any of this, and you can see the heater wires are coming in here. I had to lie down the wire feeding voltage to the plate here on pin 1, and going to the cathode resistor here from pin 3. So you can see I've taped this one down. I don't know why I did that. It lies just fine flat. So I've laid these two against the chassis here. What I did was, like I said, the board's mounted on 2 standoffs. So those screws come through the chassis and through these holes here, and there's another one here. You can see that ground lug, which also gets connected there. And there's a standoff, like I say, about 1/4 of an inch, maybe 5/16 of an inch. and I realized that that 1/4 of an inch could really save my bacon on this. So what I did was I took piece of insulating material. This is some of the epoxy card that I used to make my eyelet boards for my other amps. So I cut that out in roughly the shape of the relay board to use as an insulator to put between the chassis and the relay board, and that way I could get the relay board a little closer to the chassis and not risk shorting anything on the bottom right on the chassis. And I hope that would give me enough room to install everything. As it turns out, it did give me room. You can see right here, I just squeaked that in. So I had the relay board installed with that little insulator behind it, and it's tightened down to the chassis. And you can see this angle isn't so good. It looks pretty close here and here still. You can see I took some other pictures of that from this angle. You can see we're actually not too bad here. We've got about 1/8 of an inch distance between that pin 9, that heater pin, and here we got about 1/16 of an inch here. That still kind of bothered me. That still looks a little close to that can, and the top of the can is exposed. I did check. It doesn't. The can's not connected to any part of the circuit. I was concerned that the can might be grounded, and it was not. But I still didn't want to risk this pin coming into the contact with the top of that can and causing a problem. So what I did was I took the relay board out again, and then I double wrapped it with some electrical tape. So I put 2 layers of electrical tape over top of the can, and then I wrapped around the can with some electrical tape. And you can see there the electrical tape is bubbled up a little bit here, but there's about 1/16 of an inch anyway. And again, there's more room than appears between the can and this pin here. So that made me feel a lot better and a lot safer about installing this. And I just, one of the things I did have to do was on the bottom of this board, I had to trim all the leads on the bottom as close as I could. I was a little concerned that I might have cut something a little too close and the board wouldn't work. At this point, I've actually already tried the amp, and it's working just fine. So here's the relay board with that insulator, and that's installed. And here's the effects board installed. At the end of the day, the lead dress is actually still very good. It's under here. The effects board sits up about 1.5 inches or 1.75 inches off the bottom of the chassis. So I was able to still have these wires dressed the way that I wanted them. And just put the effects board over that. Like I say, I only had to lay down the 2 wires over at this end. So at the end of the day, we're good. What I would have liked to have seen, I think, was it probably would have worked a lot better to take this relay board and instead of install it here while you have this effects board in here as well, I think the relay board could have been relocated up to this side of the chassis. Up here, you would have had to run a few wires a little bit farther to it. They would come a little close over V1. You might have some lead dress issues, but you could probably deal with them. The foot switch for the relay board is, you can just see the edge of it right here. What I would have done then was I would have taken that foot switch and I would have put it in about here. That would have probably solved this problem as well. Like I say, this set me back a bit, and it's why this final assembly video is a little bit late. It took me a while to figure out what I was going to do about this, but at the end of the day, we're good, and we're off to the races there. Before I cut back to the assembly and checking the off-board wires and whatnot, I'm also going to cut in a little bit of a description of assembling the relay board and the effects board, what was required to get those ready to install into the amp. So that's next, and then we'll get back to the testing and assembly. I'm just working on the overdrive relay board and effects loop right now. So I'm not going to show assembling that. I've shown enough soldering and things, and if you can follow a schematic and a layout, you would be okay doing this. The relay board in particular for the overdrive is completely unassembled, so all the parts come when you buy the kit. You have to solder them in, and if you just follow your correct polarities and correct placement, you should be okay. The one thing though that I wanted to point out is I have the version of the overdrive relay board that takes its power from the from the heater supply. So a couple of things I just wanted to point out that will be getting soldered to this board once I've put the components on it. We have here the heater wires will come in here to provide the power to the relay board. That's this connection here and this connection here. They are both designated with an H. We also have from the middle tab of the overdrive pot, we will have a connection coming in here. You'll note that this coaxial cable is grounded here at the pot end. There is no ground at this end, so just the hot wire will be connected in here. We also will be putting these two wires going to the inputs of both sides of V2. That's going from this connection on COM and this connection on NC, going into the grids of V2. And then we also will have a ground going from here to a grounding lug, which will be on this mounting post right here when we install it. The only other thing we have to do is these two wires coming from the switch on the overdrive pot into the jack for the overdrive control foot switch, and then we have two wires coming off of that and going to the relay board. One coming off here, should be going into here, it looks like, yeah. And this connection here will also be going to this grounding lug on this standoff here. So that's the wires coming into the relay board. So here's the effects board. We also need to run the heater supply into to the tube that's on the effects board. That is these two connections right here, and that's for the heaters of the tube. It takes its power from B plus here after the 33 microfarad electrolytic. You add this wire in here and to this point right here, which is marked B plus. There's also a ground from this connection which will go to the grounding lug for the preamp. You will note that the master volume, the input from the master volume also comes into this board here where it's marked in, and then we have an additional coax cable that goes to the input of V3, and that comes here from this out connection. So that's the 5-6 wires that we need to connect into this board. Obviously this board is fully assembled, so it's just putting in those 6 wires. The only other thing to pay attention to here is, as I said, it gets its power from this B plus node here. If you look here, there's a jumper wire that goes underneath, and it goes to this junction right here after this dropping resistor. Before you install the effects board, you want to check what your B plus is there before you make this connection, and then make sure that once you connect this, the voltage is still the supply voltage is still the same. It will probably drop a little bit. So what you're going to need to do is you're going to need to parallel another resistor across this 22K here to lower that resistance and bring your voltage up at this node. You may or may not have to do that according to the instructions here. It says if required. Again, we just want to make sure that before we connect this up to power the effects loop, just leave that as the last one. Everything else should be fine. Fire up your amp, check it out, make sure all the voltages are good when you're testing. Check what your B plus is here, then connect this up and check that you still have the same B plus. And like I say, you can get that voltage from this point here, or from here. Probably this point or this point would be the best place to check it from. And yeah, just make sure you've got that. The other thing that I want to point out is, since they both need to use the heater supply, again the relay board to power it and the effects board to provide power to the heaters of the tube, they both need to have the heater wires come in and connect to them. So I'm working on the relay board first. The heater wires will come in here from V1, the first tube. I also will then jumper twisted pair of heater wires from these two connections over to these two connections for the heater on this tube. So as I'm preparing all of this, I will get that soldered in there, and then when I'm ready to install the effects board, I will have a flying pair of wires that I just need to solder here to provide power for the heaters in that tube. My suggestion, though, at the end of the day, would have been to move the relay board over to this side of the chassis and then just run jumper wires, maybe even take the overdrive switch instead of having it over here, take it over here, so we could keep the lead shorter and run things there, and then we wouldn't have had a conflict. We will just double check the ones that we can reach. So that orange that I can't get to, that should be coming from here, and there's just no way I'm going to reliably get, oh, you know what I can do? I can get in on the socket on the bottom if I really want to. Nah, that's going to be a lot of flipping things around, so I know that's good. If I really need to check it later, I will. So we do have, though, this orange wire that goes to pin 1 of V2. We also have an orange wire that goes from here, this turret, and that actually goes back over to pin 1 of V3. So we can check that one. That should be this. And we're good there. Then we have another orange wire that should come off of this side of this 220K, and I might be able to get in there. Yeah, we're good. We're good there. Then we have two blue wires, one that goes to pin 3 of V2 from this turret, and one that goes to pin 8 of V2 from the turret beside it. I can't really see either of those well enough to actually get at them with the probes. So that's 3 connections that we can't check with this all assembled the way it is, and I don't want to take this apart. If I really wanted to, I could clip a lead on those and check it from the other side of the socket. I don't have tubes in yet. I'm happy with the visual inspection on that. And same thing for V1. We have an orange wire that comes from here, and you can see it come out right here, and it goes to pin 6 of V1. I can't reach really in there and check that. One of the things you don't want to do is force probes in blindly and risk shorting things together, pushing wires together, or even breaking a wire. So I'm not going to check that one either. Visually it's good. The next one is an orange one that goes from here, and it goes to pin 1 of V1, and that's actually where I had, that's related to the problem that I had with this board, so I can reach that, and we're good. And then we have a blue wire coming from this turret, and that goes to pin 3. I can see that one there, so I should be able to get it. Yeah, we're good there. And then finally one blue wire that goes from this turret, and that goes over to pin 8 of V1. And again, visual inspection we'll just have to do on that. So the other things we want to check, we have a coax connection that comes from the middle of the master volume. Normally it would terminate down here on this terminal strip, but because I have the effects loop in there, it goes and terminates on the effects loop board right here. So that's this wire going here. We'll check that one. And then this added piece of coax in here goes down to that terminal strip where this wire would normally go if there was no effects loop. So we'll check that one right now. we're good there. And then this one should go to here, and we're good there. We also, as I said, there are some jumpers going between a couple of the tubes, maybe only one jumper. Let me just have a look here. Yeah, we have one blue jumper from pin 3 to pin, from pin 3 of V3 to pin 2 of V4. So that's this blue wire right here. So we'll check the continuity there. And we're good there. And do we have any other wires to check? A lot of the other ones, I'm not going to check on the speaker connections and all of that. You can see those and we assume they're good. I think we've checked all the other ones. Yes, it looks like we have. Again, I've checked all of this stuff as I soldered it. These are your 1 ohm sensing resistors to check your tube current when you're setting the bias. All of this stuff, just visual inspection is good enough for that. It all looks right. Same thing with all the connections coming in from the transformers. So that's checking the continuity of the off-board wires. And we're looking good there. I'm going to take a quick second and get set up for doing the power testing. The exciting part is coming up now. So what we're going to do, I have my notes here. We got 3 steps in checking the power supply. The first 2 steps will be with the first step will be with no voltage applied. We're just going to check that the transformers are not shorted, you know, that everything's good there. To be honest, I've checked that already, and you should check that before you solder everything in. I've already soldered that stuff in. It's okay, but I'll go through the motions and show you what you check with that. Then the next step will be checking with everything but the high voltage secondaries connected, and that will also involve powering up to check that we've got 6.3 volts across the pilot lamp, which is also feeding the heaters, and to check that we have the correct voltages coming out the secondaries. The next thing is where it gets exciting, and the part that all people who work on amps bring in their caution. That will charge up B plus in the amp. That's all the dangerous voltages. So you know, I'm no different than everybody else. Don't just fly in here if you don't know what you're doing. Once you power one of these amps up, these voltages are very high. If you don't know what you're doing, don't poke around in an amp. Don't mess around with it. And I will be being very careful when I do that step 3. One of the things that I always do when I'm working on an amp is I make sure I'm not sitting in a metal chair or connecting or you know, sitting leaning on something that's metal connecting me to the floor. I also wear shoes with rubber soles, and the big important thing is never touch anything that is going to, even using a probe where you're measuring voltages, never touch anything with your left hand. If you slip, never give an opportunity for that power to go from your right hand through your body, through your heart, and then out to ground through your other hand. That's a direct circuit, and that is what's lethal. Also, sometimes I don't even sit in a chair just to not risk grounding myself through part of the chair. But I had a teacher in high school who used to say, you know, keep your hand behind your back, because if you get a shock goes through this hand and out through your left leg, the only thing between your hand and your left leg doesn't really matter. To the 18-year-olds it did. So stand by, we'll get ready for that, and we'll do that next.